So let's go ahead and solve the search in a binary search tree problem on LeetCode. On this problem, you are given the root of a binary search tree, BST, which is important to us, and an integer val. We need to find the node in the BST that the node's value equals val, and return the subtree rooted with that node. If such a node does not exist, return null. So in this example, we have root is equal to 42713 and val is equal to 2. So we need to return the subtree rooted at 2. So in this case, it would be 213. Since this is a tree problem, most tree problems require us to solve it through recursion, which is what we're going to do. Recursion is when you call a method within itself, and we'll take a look at what that looks like in just a moment. But also, since we're using recursion, we're going to need a base case. So let's go ahead and start coding. First and foremost, we need to create our helper method, so let's do that. It's going to return tree node, so public tree node. Let's call it find value. And this method is going to take two inputs, which are going to be a node, so tree node, and the int val itself. Now we need to account for the base cases. The first thing we need to account for is if first and foremost the node they gave us is null, we need to return null. And the fact that if we scan throughout our BST and we don't find the value that they want, then we also need to return null. So if node is equal to null, then return null. And then the second condition or second base case we need to account for is if in fact the value at the node is equal to the val that they gave us, then we need to return that node. So if node.val is equal to val, then return the node itself. Okay, now we need to take advantage of the fact that we're in a BST, a binary search tree. And I mentioned that it's important that we're working with a BST. And why is that? That's because at any given node, the values to the left of that node are going to be less than that node, and the values on the right are going to be greater than that node. So for example here, 2, which is on the left of 4, is less than 4, and 7, which is on the right of 4, is obviously greater than 4. Now this principle is applied to the rest of the tree as well. So at node 2, the values to the left of 2 are less than 2, and the values on the right are greater than 2. But because we're on the left subtree, even the values to the right of 2 should be less than our first initial node. So in this case, 3 is less than 4. So why is this important to us? That's because we're going to see what the value they gave us is, and we're going to compare it to the node that we're currently on. If that value is less than the value of the node that we're currently on, then we're obviously going to check the left subtree. Otherwise, if it's greater than what the value of the node that we're currently on, then we're going to check the right subtree. So let's go ahead and do that. If node.val is greater than or equal to the val that they gave us, then we're going to write something within this block of code. Otherwise, if node.val is less than or equal to val, then we're going to check whatever is in this block of code. Now let's move on to writing what within these blocks of code. So this is where the recursion actually happens. What we're going to do is we're going to create a tree node left in this case, because we're on the left subtree. This value is going to be equal to the result of the method we just created that takes node.left and val. In other words, we're checking the node to the left of the root node, and we're storing the result in left. And then once we find our value on the left, we need to return left. And similarly, if we go to the right side, we need to store in a value called right the result of find value of the right node. So node.right and val, and we need to return right. And we'll take a look at an example now. And then finally, we need to include a final return statement, because otherwise LeetCode would give us an error and it would tell us there's a missing return statement. But it's important to note that these blocks of code cover every base case. It's just for LeetCode not to compile an error. Also, if there are duplicate conditions or bugs that somehow managed to bypass this block of code, we're going to return null. So this is essentially a fallback statement if any bugs bypass through this code. So now let's take a look at example 1. Once again, we have root 42713 with a value of 2, so we need to return the subtree rooted at 2. So, there's one more thing we need to include here. Return, obviously, the method itself that we just created that takes the root that they gave us in the given and val. Okay, so let's take a look at this example. Within this statement, we need to return find value of 4 and 2. So we're going to call this method here. Is 4 equal to null? It's not, so skip this. Is 4 equals to 2? It's not, so skip this. Okay, now we need to check if 2 is greater than or less than 4, and obviously it's less than 4, so we're gonna go to this if statement. And within left, we're going to store the result of find value, which we're going to call with node.left and val. So in other words, 4.left is 2 and val is still 2. So we're going to store within left that result. So we move back up here. Is 2 equals to null? No, it's not. Is 2 equal to val? Yes, it is. So within left, we're going to store the result, which is node. And then we're going to return left, which is node. And that should work. Let's submit it. Okay, perfect. So it works. Let's just take a look at example 2. Once again, we need to return find value of root and val, which in this case is 4 and 5. Is 4 equals to null? It's not. Is 4 equal to 5? It's not. Is 5 greater than or less than 4? It's greater than, so we need to check the right subtree. Within right, we need to store the result of find value of node.right, which is 4.right, which is 7, and val, which is still 5. So we go back up here. Is 7 null? It's not. Is 7 equal to 5? It's not. Is 5 greater than or less than 7? It's less than, so we're going to go to the left of 7. So within left, we're going to store the result of find value of null and 5. Is null equals to null? Yes, so return null. And if you keep going back with the recursion statements, eventually you're going to return right, I believe, which is null, because left is null, and so on and so forth. So the final result should be null. And since we submitted and ran through all test cases, that means our code works. And yeah. So I hope you found that video helpful, and thanks for watching.